I want to go over the solution for last week's problem dealing with determining the probability that the random variable x is less than 81,000. Uh, in that problem, if you recall, you were given the mean of 87,000. You were also given that the population is assumed to be normal. Therefore, since the population is assumed to be normal, we can use the standard normal distribution, or the so-called continuous probability distribution. Since we're dealing with a population, we know that we have to determine the number of standard deviates, or z-scores, from 87,000 to 81,000. And this is a little formula, right? Z is equal to random variable x minus the mean divided by the standard deviation. And that's the formula we would use when we're dealing with population data. So in this case, yes, 81,000 minus 87 divided by 4,000 is a negative 1.5. So that's what I'm saying down here, is that, in other words, from the mean of 87,000 to the value of my random variable x happens to be a negative 1.5 z's, or 1.5 standard deviates from the mean. Now, to determine the area in question, less than, so we want to determine the area to the left of 81,000. So we've come up with negative 1.5 z's, and from that standpoint, we want to be able to determine what the area is. As I pointed out, this is the, in Appendix AD, or D1, I believe that's what we're titled, yes, Table D1 from Appendix D. And if we go a negative 1.5, right, negative 1.5, since this particular table is looking at 50%, so it doesn't make any difference if we're looking at the right or the left side of our mean. One is simply the mirror image of the other one. So in this case, since we've gone to the left, we would be looking at 1.5, but a negative, and that gives us 43.32%. So that area under our curve, if I can get back over there, corresponds, as indicated, 43.32%. Okay? So the area in question, in other words, what I'm saying, let me be kind of be a little redundant here. The area between 87,000 and 81, which in z terms is negative 1.5, corresponds to 43.32. That is the area between 81 and 87. So to determine the area to less than 81,000, this particular area here, as indicated, we would take, that should be, let me just change that, I apologize. That should be 0.5, or 50%, well, I'll get that right yet, I apologize again, minus the 0.4332. So let me just repeat. We know, in other words, that we go a negative 1.5 z's. That corresponds to that area, 43.32, from Table D. If we want to determine what is less than 81,000, right, we would simply take 0.5, since that table is dealing with half of the standard normal, minus the corresponding area of 0.4332, which gives us 6.68%. So once again, that is just a quick overview of the solution for last week's problem, dealing with what is the probability that our random variable x will have a value, in this case a sales value of less than $81,000. So once again, that's pretty much straightforward. We're dealing with population data. When we have population data, we must assume that the population has a normal distribution in the computation of the mean, in this case of 87,000. Hopefully this helps for your learning this past week in determining, coming up with the probability of determining the value for our random variable x, and in this case is indicated less than 81,000.